Hello, I'm Angie Jones, and I'm a Principal Developer Advocate at Applitudes. And today I've come to tell you a story about the build that cried broken. But let's first talk a little bit about continuous integration, just so that we're all on the same page. The process starts when the developer checks in their code into a source code repository, and then that code is integrated into an existing code base and is built into what would be the new version of the product. From here, the automated tests are run as part of this build process to ensure that the new changes don't break anything. And then finally, a report is generated, which informs the developer if her check-in is good or not. As I'm sure you all know, all of these pieces must work together in perfect harmony in order for this to be a healthy and reliable process. However, there's one piece here that gives most teams trouble. Can you guess it? Yep, it's the tests. Fortunately, there's an ancient Greek storyteller by the name of Aesop who seemed to know a little something about continuous integration, even all those centuries ago. So Aesop, he left us a few classic tales or fables that we can apply to our CI tests, such as the shepherd boy who cried wolf, also known as the boy who cried wolf. As the story goes, there was a young shepherd boy who was responsible for looking after the sheep in his village. And the thing about this kid was that he was a prankster. Just for kicks, he'd often yell out, "Wolf, wolf," and all of the village people would come running, concerned about their sheep, only to find the boy laughing hysterically at this little joke of his. Now, this went on for a little while, and the villagers, they would fall for his prank the first 3 or 4 times. But eventually, they became hip to his game, and they disregarded his future alarms. Well, one day, a wolf really was coming. And the boy, he screamed at the top of his lungs, "Wolf, wolf!" However, no one paid him any attention. The sheep, of course, perished. For many teams, their continuous integration builds have become just like this young shepherd boy. They're crying, "Broken, broken." And in a state of panic, team members, they come and assess the build. Yet time and time again, they find that the application is in fact working, but the tests are faulty and giving false alarms. Eventually, no one pays attention to these alerts anymore because they've lost faith in what was supposed to be a very important indicator. This used to be my life. I was working on one of many automation teams, right? And I was working with this specific team where our tests were in pretty bad shape. So much so that just like the villagers, we stopped paying attention when our build cried, "Broken, broken." And when the bill was read, we'd automatically assume that it was a problem with the test, and we just ignore it, right? Until one day, one of our product people needed to demo the app to a potential customer, and the demo failed. Gasp, I know. So our manager was questioned about this and asked why we haven't been testing these important features. And when we looked through the bill, we saw that, okay, of these 4,000 tests, some of them were dedicated to those specific features. And yep, they sure did fail. But we missed it because we stopped listening to our broken builds. We had completely lost trust in our CI tests, and that day, my manager demanded that we fix this. So take this journey with me as I share just how we did this. The fox and the goat. A fox was walking along the trail one hot summer day, and he became quite thirsty. And he noticed a well of water nearby, so he hopped in to get a sip. Now, once he quenched his thirst, he tried to climb out of this well, but he was stuck. He tried and he tried with no luck, and eventually he gave up. But not to worry. A bit later, a goat was strolling along the same path and he heard noises from the well. So he went over, he saw the fox, and he asked, "Hey there, Mr. Fox, what are you doing down there?" And the fox responded, "Oh, I was thirsty and I came down for a drink. The water is delicious. Come on in, have some." So the goat jumped in the well. The fox jumped on the goat's back and was able to escape, leaving the goat down there to struggle. The moral of this story is to look before you leap. Our team wanted to do continuous delivery, and everyone told us, "Yeah, it's great down here. Jump in, but you'll need to automate your tests. And you'll need to do so ideally within the sprint." So we jumped in, and automating the tests became our focus. And this was driven by the metric of 100% of our tests must be automated before we close out a sprint. But this shouldn't have been our goal. We're doing in-sprint automation, but the builds are red. And yet we're steadily adding more and more tests. Why? We have 4,000 tests that we ignore. Why are we adding more to this? Information is worthless within an ignored build. So looking at this in hindsight, our true end goal was to obtain fast feedback. But our judgment was clouded by these arbitrary metrics. We had lost our way. The lioness and the vixen. One beautiful afternoon, a lioness and a vixen, they took their kids outside to play. And as the children were off playing, the mothers began to chit-chat. And you know how moms are. They can't help but to brag on their children. And as they were doing so, it became a bit of a competition between the ladies, and they were trying to one-up each other with the brags. So the vixen, she talked about how witty and quick her kits were, and the lioness talked about how big and strong her cub was. And then things got a little bit heated. And the vixen took a verbal jab by saying, "Well, too bad you only have the one. I have a whole litter." And the lioness, she paused. And she held her head up high and she said, "Yes, I only have one, but he's a lion." The moral of the story is quality over quantity. We were adding all of these tests and not taking a moment to think about what were the right tests. Which ones could provide valuable information to us? Again, if our end goal is fast feedback, then having thousands of low-value tests running isn't exactly in line with that, right? The questions we should have been asking ourselves are, based on risk and value, which scenarios would cause us to stop an integration or deployment? Which ones exercise critical core functionality? Which ones cover areas of the application that have historically been known to fail? Which ones are providing information that's not already covered by the 4,000 other tests that we already have running in the pipeline? And once we've narrowed the quantity down, we can truly focus on the quality, because if there's one lesson that I absolutely learned the hard way, it's that tests that are running as part of CI/CD, they must be of high quality, because flaky tests are the death of a continuous integration process. They are a sure way to lose all trust from your team members. And I want to spend a little time on this because so many preach that we should avoid flaky tests, but few tell you how to do this. So I'm going to share some tips and techniques that I use to strengthen our tests. Surprisingly, to probably no one, many of our problematic tests were the UI tests. As we were cleaning up these tests, some of the most common issues were things like no identifiers on some of the web elements, so needing to use CSS or XPath selectors instead. When using CSS and XPath selectors, relying on the page structure became an issue. For example, scripting your test to click the second button. That could be a problem when the structure of the page inevitably changes. The use of identifiers that are most likely to change, such as label text, for example, and then in modern web development, the DOM is now dynamic, right? So our identifiers need to be smarter. With this now fancy DOM and asynchronous applications, it also became pretty important to incorporate waiting into our tests. So we removed all of the hard-coded sleeps and waits, and let me tell you, if you're still sleeping in any of your tests, wake up, all right? Trust me, this is not what you want to do. So we changed the test to wait conditionally for whatever it is that we were expecting to happen. For example, waiting for loading indicators to disappear or Ajax to finish executing. And sometimes we needed to wait for things that weren't happening at the UI level. For example, API responses or database transactions. So many of the testing tools, they have sophisticated APIs now that will allow you to wait on a condition to be met, as opposed to just blindly waiting for some specific amount of time. So we use those to help us out. We also realized how difficult it is to manage test data, right? Especially across thousands of tests. For example, let's say that our test searches some website, Prime Video or something like this, for The Marvelous Mrs. Maisel show, and we get 3 seasons returned. Well, when season 4 comes out, what's going to happen? All of a sudden, our tests are going to fail. And no one wants to chase tests like this, right? So we had to determine what's our source of truth. Is there an API or a database call we can make to give us that answer? And if so, utilize that in the test assertion as opposed to hard coding the expectations that could very well change. Also, because many of our UI tests were flaky, we modified them to use shortcuts, also known as code scenes, in many cases. For example, let's say that we want to test that we can increase the quantity of a product in our cart. Well, if I'm testing this UI as an end user, the flow is going to go something like search for a product, find the specific product in the search results that are returned, click on that product to be taken to the product page. From there, we can click the add to cart button. Then we need to go to the cart, so that's another button click. And then finally, we can test what it is that we wanted to test. That's a lot of unrelated activity going on, and a bunch of things can go wrong before we even get to the test itself. For example, let's just say search is broken, right? Well, that's great to know. I agree with that. However, in addition to our search test failing, now we have our shopping cart test failing as well. Why are the shopping cart tests blocked because search is broken? That doesn't make sense, right? This was another factor that annoyed the teams with the bill. You break one little thing and you have hundreds of tests that are all failing, telling you the exact same thing. I don't need 200 tests to tell me something, right? One is enough. So we started using these code scenes or shortcuts, and they're nice little ways to cheat within your scenario. So in my case, if I'm testing quantity increases in the shopping cart, then let's bypass search. And maybe we can even bypass the product page, right? Because that's yet another dependency. If there is an API, even an internal one, that would allow me to simply add the product to the cart, then that would help out a great deal, right? And if there's a button that does this, then there's an API or some call being made on the back end of that. So within your scripts, use that as a code sync to just make that call, and then you can directly go to the shopping cart and do your testing. All right. Now, not only does that eliminate the dependency on other features and flakiness with UI testing, but it also helps out with that end goal. Remember, fast feedback, because these types of tests are much quicker to write and also much quicker to execute. All right, story time. So there was an astrologer, and this guy was really deep, right? He was so into the stars and the moon that he didn't bother talking to fellow human beings much. Well, the astrologer was out one evening for a walk, and he was gazing up at the stars in an attempt to read what was coming in the future. And just as he thought he was making sense of the constellations, he fell into a big puddle of muddy water. And the moral of this story is to pay attention to what's in front of you. We were so gung-ho on planning for the future that we neglected to pay attention to what was right in front of us. Everyone on the team was focused on new feature development and adding new tests that we didn't spend any time monitoring our existing tests or maintaining them, right? We didn't take the time to listen to what the tests were telling us, what patterns were revealing themselves. We had come to value new code over working code. And with this realization, we understood that we had to take a step back. Because you see, tests are living, breathing creatures. They must be monitored daily if possible. So our immediate goal was to ensure that the bills were green. Well, we had hundreds of tests that were in bad shape. So this couldn't be like a little fix a test when I have a spare moment kind of deal. No, we needed to hunker down and focus on this. And to accomplish this, we decided to create tasks within every sprint just for monitoring the test. And the rule was anyone could take this, right? So in our 2-week sprints, we'd have 2 tasks, 1 per week. And someone was basically on duty each week to monitor and maintain the test. And this was their sole responsibility for that week. Now, this got us some great momentum going. However, with so many failing tests on every build, it became really difficult to know what to go after. So we decided to keep our test results in a database. Nothing major, 1 table, 5 columns, as you see here. But this helped us triage this better. So anytime a test was executed, the test would write its status to the database. And what this now gave us was a way to gather statistics around tests. So we could do things like sort the results to see which one is most likely to fail, right? So this can indicate flakiness or problematic areas within the application. This is a nice starting point. Or we can see which ones have failed for the very first time. Now that's interesting, right? Because these are more likely to be real bugs in the product. Everything was working just fine, and now all of a sudden something fails. That could be a bug, right? So this was extremely helpful, this database, in helping us to figure out what to focus our attentions on in those sprints. Let's talk about the farmer and the stork. So the farmer was having a problem with a flock of crane birds that would come and they would dig up all of his planted seeds. And after this happened a couple of times, he decided to plant a trap for them. Well, the crane birds, they were on their way to the farm when they ran into the stork. and they invited their new friend to come with them to the farm to get some food. Well, everyone loves free food, right? So the stork followed along without much hesitation. And when the birds got to the farm and began to pick at the seeds, they were captured by a net that the farmer had cast. The stork immediately began to plead his innocence, insisting that he just met the other birds and he had no idea that this was stolen goods. And the farmer frowned and said to the stork, "I don't care. Birds of a feather flock together." Or in other words, one bad apple spoils the whole bunch. We had been making great progress cleaning up our tests, and slowly but surely the number of failed tests were decreasing each day. And so we would get really excited and communicate this to the rest of the team, and nobody cared. Why not? Because the bills were still red, right? All it takes is one flaky test to make the entire bill red. So even if most of the tests were okay and green, it didn't matter. No one trusted the build as a whole. So we had the great idea to separate the test into two different bills. One for the reliable, trustworthy test, and one for the unreliable test that we still needed to investigate. And we ran both of these builds, but the trustworthy build was the one for the team to use for CI. Now, there were a couple of reasons why we kept both of these buckets of tests running. One is we wanted to continue to track the intermittence of our tests, because remember, they're reporting their status to this database. So we still wanted to, get that information on them. And then two, very important, out of sight is out of mind, right? If we just took the bad tests out, there would be no visibility into just how much debt we were accruing. But with this approach, we could easily show a build and say, listen, we need time to stabilize these tests, right? It's getting out of control. So our goal was to have less than 1.5% unstable, which of 4,000, that would be 60 tests, right? So we felt pretty good with this 1.5% number because Google's number is 3%. So we were doing better than Google, right? Or at least that was our goal. But seriously, if we went over this number, then new development stops. That's the rule. It's all hands on deck to get the test failures back down. The approach we used to split the test into buckets was test annotations from a test tool. So we used unstable for tests that needed to be updated, and we used bug for tests that are failing with a known bug. Also, once we think that we fixed the test, notice I said think, we didn't immediately move it back into the reliable bunch, right? We let it run maybe a good 10 times successfully in a build with other tests running before we would deem it trustworthy again. And for anything that we marked as unstable, we opened a task for it, and that would go on the backlog. And what I loved about having this in the backlog is that it got prioritized along with all of the other tickets within the backlog. So we based the priority on how important the test is. So we would pull what we could manage into the sprint, and in addition to whoever was on duty that week, other team members could also pitch in and grab one of these tasks if they had time to do so. Now, one lesson I learned while fixing up the test is that if you find yourself patching, it may be just better to delete that test and start over, right? I heard a talk from Professor Aesop Fable, and he's a professor at the University of Maryland. And Dr. Meeman, he spent a summer working at Google and actually studying the fragility of text. And he found that after 3 edits of a test, that test is exponentially more likely to become flaky. And as I was wrestling with this particular troublesome test for about an hour, and I couldn't get it to work, I remembered Dr. Mima's words, and I thought to myself, yeah, I bet this is like the fourth attempt at, messing with this test, right? So instead of fighting the test, I killed it. I deleted it and I coded it from scratch, and then it worked, right? So it took me 25 minutes to rewrite this entire test versus an hour of struggling with no success. Also, the test went from 113 lines of spaghetti code to 38 lines of clean code. So don't be afraid to delete tests when you need to. Rewrite them if you have to. Sometimes it's okay just to delete them if you find that they're no longer providing value. All right, one more story. The dog and the hare. A dog and a hare, they got into this heated debate about which one of them was faster. And after a few minutes of squabbling, they decided to settle it once and for all with a race. The hare was smoking the dog, who eventually caught up, but not enough to pass the hare. So frustrated that he was losing, the dog grabbed a hold of the hare and bit him. The hare screams out, "Bro, what are you doing?" The dog apologizes, he licks the hare's wounds, and he begs him for a rematch. The hare, being the kind, forgiving soul that he is, he agreed to another race. So they race again, and just like the last time, the hare is leaving the dog in the dust, and also just like the last time, the dog is able to grab him, bites him again. The hare yells out, the dog apologizes, and again, he begs for a rematch. The hare says, "Nah, bro. 1 minute you're biting me, the next you're licking my wounds. I can't trust you. I don't know if you're friend or foe." Now, once we got our failed test down to less than 1.5% and they were in a healthy state, we had to make sure that the new test that we introduced didn't become a problem, right? It took a lot of effort to get our bills to a place where we trusted them. And all you need is one new test coming in and messing up the program, and then everyone's rolling their eyes again, right? So if you have a lot of people contributing, or you see that you're introducing a high number of flakiness with new tests, what I recommend you do is put these tests into a private build that only you're monitoring, right? It's not part of CI. And after maybe 10 successful runs of this test, then you can add it to the CI build. The thing is, we sometimes are asking people to trust tests that we don't yet trust ourselves, right? And this is especially true when you have new feature areas or new people who are joining the team. And I do realize that this is a lot of overhead because, now this is yet another bill that you have to manage. But the upside of this is people are going to get in the habit of coding responsibly because they don't want to manage all of this. They want their tests to go into the big league right away. So with that, you're a little bit more careful to develop this in a great way. Okay, how the story ends. So once we got to a good system where the bills were only read when there was something wrong with the app, we were able to use CI as it's supposed to be used, right? Where developers are watching the bills upon check-ins and they're making sure they're okay. So we had our 4,000 and counting tests. We achieved the goal where there were no more than 1.5% of the tests that were unstable. And we honored that rule that if we went above this number, we were out of control, and stabilizing existing tests became a higher priority than writing new ones or even writing new features. The reliable build was green unless there was a change with the application. This is how CI/CD is supposed to work, yes? So that change could be a bug, or it could be an intended behavior change to the application. In either case, the test did what it was supposed to do, which is great. And most importantly, the team came to trust the results again. And that's the end of the story. Thank you all so much. I hope that this has been helpful for you.